Let's solve problem 2.2 for Microelectronic Circuits 8th edition by Sedra and Smith. So this circuit here uses an op-amp that is ideal except for having a finite gain of A. Measurements indicate that Vout is 2.5 volts when Vin is 1 volt. And what is the op-amp gain A? So these properties I've listed here in the top are ideal op-amp properties. So let's review them and figure out which one is not being upheld for this problem due to the finite gain. So first we see we have property 1 is infinite input impedance. That means that the input impedance in this rail to the positive and this input rail to the negative terminal of the op-amp should be infinite. Now the second property says zero output impedance. So that would be this output terminal of the op-amp, R should be zero. And then we have zero common mode gain, or equivalently, infinite common mode rejection. So my professor called this a virtual short, but it's basically like if we connected these two rails with a wire and we took a voltage drop across it, there should be zero voltage drop between these two rails. Then we have infinite open loop gain A, which is not being upheld in this problem because we see that we have a finite gain of A that we need to solve for. And then lastly, we have infinite bandwidth. This just means that the frequency response of this op-amp goes for infinite frequency. It's not really important for this problem, but if you're analyzing a network of op-amps, that would be important. So let's start by solving for our gain A. In order to know what the gain A is, we need to know what the voltage at this node is, which I'm going to label V positive. Because it's not just Vn, right? We have these resistors that are taking out some of Vn. We have to do a resistor division calculation. So V positive will be Vn multiplied by what is consumed by this 1 kilo ohm resistance. So it would be 1 kilo ohm divided by 1 kilo ohm plus 1 mega ohm, since they are in series. So we get that V plus is equal to 1 volt times, so it's basically 1 over 1001. So we just get 1 over 1001 volts. Perfect. Now, when we have this ideal op-amp with a finite gain, we can use this expression. V out equals the gain times that voltage at the positive rail. So then we can solve for A equals V out over V positive, which is equal to 2.5 volts divided by 1 over 1001 volts. And I'm getting 2,502.5 volt per volt. Note that the gain, the unit should be volt over volt. For every volt that I get in my positive rail, I'm returning 2,502.5 volts in my output. That's essentially what this is saying. That's the problem.